Okay, today we'll be taking a look at some more advanced string slicing in Python. So in the previous video, we talked about basic string indexing and basic string slicing. So we'll stick with this same string, computer. So let's do word equals computer, and then we'll print word from, we'll just take a random substring right here. So from 1 to 5. So we get OMPU, this right here. So we remember the start of our range 1 is inclusive, so we get O, and then 5 is exclusive, so we don't get T, so we get OMPU. So today we're going to introduce a third variable called stride. So it actually goes after our ending index and looks something like this. So stride basically specifies how many characters to skip forward at each step. So if we take a look at our range right here, OMPU, we would start at O because our stride is 1. We go over 1, M. We go over another character, P, and then another character, U. So with a stride length of 1, we get everything in this range. So if we were to run this, we would also get OMPU. Perfect. So what if we were to do a stride length of 2? So let's try that. So given the same range, 1 to 5, we now have a stride length of 2. So we'll start at O, but this time instead of going 1 over, we go 2 over. So we'll go from O all the way to P. And then we'll count 2 more to T. But T is out of our range. So what this should print is just O and P. So we'll run this, OP, perfect. So now let's try a larger range. We can just do like 1 to 7, something like that. 1 to 7, and let's try a stride length of 3, right? So now let's take a look. So from 1 inclusive to 7 exclusive is this, right? So with a stride length of 3, we'll be basically counting 3 characters at each step. So we start at O, and we go 1, 2, 3 to U, and then 1, 2, 3 to R. But R is out of our range, so it's just O and U. So let's run this. We get OU. So stride can also be used without specifying a start or an end to a range, just like we discussed in the previous video. So actually we can just omit both of these, the start and the end of our range, and only specify a stride, right? So let's try a stride of 2, right? So this will look at the entire string with a stride length of 2, right? So we'll go from C all the way to R, right? And with the stride length of 2, we're basically getting every other character. So we start at the beginning, C, we move over 2 to M, 2 to U, and then 2 to E. So let's print this. CMUE. Perfect. So we can also do this with any combination of, specifying a start or specifying an end or not specifying either. So we can just, for example, start this at like 2, right? So this right here will start at index 2 and go all the way until the end, right? Because you see, we start at 2, we don't specify an end, which means we go to the end of the string, and we have a stride length of 2, right? So we'll start at M, go to U, and then E. So this should just be MUE. Let's run this. MUE. Nice. So now that we have basic strides covered, we can look at negative strides. So what we can actually do is do a negative stride with -2. So what this will do is instead of starting from the beginning of the string going left to right, we actually start at the end of the string over here and go right to left. So what this will do is basically look at the whole string starting on the right and then move left every other character basically. So we start at R, right? We go 1, 2 to T, and then 1, 2 to P, and then 1, 2 to O. So let's run this. RTPO. right? So we can also try -1, right? So -1 basically will just print our string computer, but backwards, right? Because we start on the right and we move over 1 at each step, right? So let's run this. We get computer backwards. But now what if we wanted to use a negative stride within a given range? So this is where it gets a little confusing. So let's take a look at a regular range with no stride using negative indices, right? So let's just take this for example, right? So let's remove stride. And to get this range, we would start at -7 and go to -2, right? Let's print this, -7 to -2. We get OMPUT, exactly what we highlighted here, right? So the problem with negative stride is if we were to add a negative stride right here, let's try like -1, right? We would think that this should print OMPUT, but backwards, the TUPMO, right? But this actually doesn't print anything. So the reason is when you specify a negative stride, you actually have to flip your start and end indices basically, right? So if we were to look at this same range, in order to use a stride of -1, we would actually have to basically count our range from right to left. So now our start would be -3 because it's inclusive, and then it would end at -8 because it's exclusive. So we would actually have to do -3 to -8, right? -3 to -8. Now with the stride length of -1, we'll get what we wanted. TUPMO. Let's try this. TUPMO. So the same applies with positive indices, but with a negative stride. So if we wanted the same thing, right, but we want negative stride of 1, but use positive indices for our start and end, instead of doing 1 to 6, we would actually do 5 to 0. All right, let's try that. 5 to 0 covers this range with the stride of -1. Nice. We get the same output. So when you don't specify a stride, you basically specify the start and end of your range just regularly, right? Starting left to right, regardless of whether you're using positive or negative indices. But when you want to use a negative stride, you have to basically flip your start and end indices. So you have to work from right to left when you use a negative stride. So we can cover the same range, but now with like a stride of -2. So we're going 5 to 0, which is this range right here. And now let's try with -2. Run this, get TPO, which is T, and then P, and then O. Right. I hope that helped.